Dear students, today we are going to see some more interesting and important questions from Narendraavasthi sir's physical chemistry, redox reaction. Come on, let us discuss few more questions from this session. Calculate the mass of anhydrous oxalic acid which can be oxidized to carbon dioxide by 100 ml of an permanganate ion solution. Here 10 ml of which is capable of oxidizing 50 ml of 1N I-2 So here in this question, basically, two main things we have to identify. First and foremost, here they have given in the question only, calculate the mass of what it is, anhydrous oxalic acid. So that one we have to identify. The second one, which can be oxidized to carbon dioxide by 100 ml of permanganate ion. So 100 ml of permanganate ion, they did not mention anything. So that comparison it is available. See here N1 I-2 I2. So here they did not mention. So we have to identify the normality of potassium permanganate. So normality, if we found out, easily we can go and identify the mass, that is given mass of anhydrous oxalic acid. I hope you got that idea. How do we solve this problem? Yes, come on. Let us go and identify here normality of KMnO4. So normality of KMnO4, how to identify? It is a comparison point, right? So we can bring that formula N1V1 equal to N2V2. Yes, I hope you got that idea. N1V1 equal to N2V2. So N1 we can take it as a, what it is, KMnO4. And N2 it is I minus. I hope you got that idea. Okay, come on. Now let us apply the value of all these points. So N1 we don't know, we have to identify, and V1 it is what it is, 10 ml. Right, here 10 ml, right? So here 10 ml equal to N2, it is 1N, and V2, it is 50 ml. 50 ml. Okay, now we have to identify N1 equal to N2, right? Here N2 V2 divided by V1. So you will get what it is, 1 into 50. And we can apply the value here. So here 10. So you will get what it is, 5. So normality of KMnO4. Normality, you got that normality of KMnO4 equal to 5N. Yes, we got it. Now we have to identify the equivalent of potassium permanganate. Equivalent of KMnO4. So equivalent of KMnO4, how to identify? That is the formula, normality into volume, right? So normality, it is 5N. And volume C, they have given it is oxidized by 100 ml of an permanganate solution. So it is 100 ml, right? So volume, it is 100 ml. So 100 ml, we can convert it into liter. So that means 0.1 liter. Can we convert in this way? Yes. So you will be getting what it is, 0.5 equivalent. So what is the answer for this equivalent of KMnO4? 0.5 equivalent. Yes, we found that. Now we have to identify that. What it is, mass of oxalic acid. So mass of oxalic acid, for that we have to identify molar mass of oxalic acid. So here molar mass of oxalic acid. So molar mass of oxalic acid, generally oxalic acid, here anhydrous they mentioned. So anhydrous means there is no water. So H2C2O4. So H2C2O4, easily we can identify what it is. It is 90 gram per mole. Okay, when you calculate each atom, right? Next point here, let us identify that oxidation point. So here H2C2O4 converted to carbon dioxide, right? So half reaction, it is redox reaction. C2O4 2 minus, which is converted to CO2, right? So that means here in this point, here per atom 1 electron. So that means here 2 atoms are available. So 2 atoms, since 2 carbon atoms. So since 2 carbon atoms, N factor it is N factor. So N factor, it is 2 electrons. See, in that even previous video also we have gone through this kind of question, that oxalic acid, that oxalate ion comes means it is 2 electron, that is N factor, number of electron change that you have gone through, right? Okay, the same idea only, just to bring it here. You have to find out the oxidation state, and here also you have to identify the oxidation state. Here you will get +3 and here you will get +4. So that means number of electron change, it is 1. So here 1 means here per atom 1 electron. So here 2 carbon atoms are available. So 2 carbon atoms, number of electron change, it is 2. So that N factor, it is 2 electron, right? I hope you got that idea. Yes, fine. Now here equivalent of oxalic acid, we have to identify equivalent weight of oxalic acid. So equivalent of oxalic acid, what is the formula? Here molecular mass by N factor. That is what we are finding, that N factor. So molecular mass, what it is, 90 divided by N factor, what it is, 2. So that means here 90, it is gram per mole. Right. So here 45 equivalent per mole. Right. Now the next point here, mass of anhydrous. Now the main point we are going to check mass of what it is, equivalent mass of anhydrous oxalic acid. So mass of anhydrous oxalic acid, that is equivalent into equivalent weight. So equivalent, what we have identified here, KMnO4, we have to combine, merge both the thing, right? So here equivalent of KMnO4 0.5. Okay, now I can apply the value here. So here 0.5 into equivalent, here 45 now. So here 45. So what is the answer you will be getting when you calculate these both? You will be getting this equivalent per mole, right? The unit and all very important. So you will get what it is, 22.5. Here 22.5 grams. So given mass, this is actually a given mass. So this much mass we have taken for what it is, reacting purpose, that point only. Okay, I hope you got that idea. Yes, come on, let us go for that point of the next one. So in this, so here I just bring that point for you to remember. So this is the answer. So 22.5 gram, that is given mass of oxalic acid. So H2C2O4. So H2C2O4, what it is? H2C2O4, right? H2C2O4. So this is, come on, let us check the answer here. Here, this is the point, right? So 22.4 gram of anhydrous oxalic acid. Yes, we got the answer. Option B is the correct option. See here, option B is the correct option. Here is the answer. So this is the answer. I hope you got a very good clarity about this question. See, when we are getting such kind of question, same value they will not provide. They will give the same concept. So we have to be thorough when we are looking at the question twice, thrice. If you are going to read, you will get that idea how to go for it. See, here also they did not mention that normality. Here one point, some key points will be there. So through that we can hold that point, right? Come on, let's go to the next question. The next question, a mixture of sodium hydrogen oxalate, that is sodium bioxalate, and potassium bioxalate oxalic acid required equal volumes of 0.2 N KMnO4 and 0.12 N sodium hydroxide separately. What is the molar ratio of NaHC2O4 and KHC2O4.H2C2O4 in the mixture? See, here they have given two important points to be noted down. Here, a mixture of sodium bioxalate and potassium bioxalate dot oxalic acid. So these both are mixture, and this is one sodium bioxalate is another compound. So these both mixtures required equal volumes of 0.2 N, that is 0.2 N normality of potassium permanganate, and 0.12 N sodium hydroxide. So this is oxidizing agent, that means redox reaction, as well as acid-base reaction. So see that separately it has mentioned. So what is the molar ratio of sodium bioxalate and the mixture of potassium bioxalate and oxalic acid in the mixture? Okay, now molar ratio we have to identify, and it is very simple. As I mentioned, redox reaction also it is there, and acid-base reaction also it's available. Why acid-base? Here sodium hydroxide, and redox reaction it is KMnO4 versus this acid. Okay, so come on, let us identify that answer for this when we are analyzing this question. Okay, now here as I mentioned here, NaHC2O4 and what it is, KHC2O4 dot H2C2O4. So these both are mixture, and this is one compound, right? Okay, so this is a mixture. You please remember, already I explained, but still I would like to mention here. Now we have to identify that normality they have given separately. So KMnO4 normality, KMnO4 normality, and NaOH normality we have to identify. Okay, now KMnO4 normality, it is 0.2 N and here 0.12 N, and volume how much, here we have to identify both in liter, right? Okay, so here what they mention, equal volume they mention. See, both are equal volume. So these 5 liters means here also 5 liter, like equal volumes. Now we have to identify the molar ratio. Okay, molar ratio. I hope you got that idea how to analyze this question. That's what I have given a data, each and every points. Okay, now equivalent of KMnO4, that is potassium permanganate, is equal to equivalent of NaHC2O4 and what it is, equivalent of what it is, potassium bioxalate and oxalic acid. That is a mixture, right? potassium bioxalate C2O4 and H2C2O4, right? Okay, now these both, which one? Both here KMnO4 and mixture. Which mixture? These both mixture acts as an oxidizing agent. Okay, so oxidizing agent. Right, now which is acts as a reducing agent? So oxalate ion acts as a reducing agent. As I mentioned, redox reaction as well as acid-base reaction, that is what. Okay, so you got that idea about all these points and data. Okay, now let us go and find the value. Here what it is, NaHC2O4. It is N factor, what it is? The N factor, here carbon is there, no? So as I mentioned, oxalate ion, how many carbon? According to that oxalate, it will be per carbon, it is 1 electron exchanges. So that means 2 carbon is available. So the N factor, it is 2 electron. Right, and the same way this mixture KHC2O4 dot H2C2O4. So for this, here you will get 2 into 2 because here 2, here 2. So both here 4 electron. That is N factor. These both also N factor. So how many electron exchange? That is N factor. Right, now you got that idea about N factor of these both. Okay, these both N factor, you got that idea. Okay, so please remember that N factor we required for equivalent mass to find out. Okay, now here here I just change this, NaHC2O4 and KHC2O4 dot H2C2O4. These both are mixtures, right? So this one we can keep it as a X mole because molar ratio they are asking, no, and this we can keep it as a Y mole. Right, now in this here this point here, total equivalent for KMnO4. So total equivalent of KMnO4, here how many number of electron change? That means how many N factor? So here 2x plus 4y. Why 2x and 4y? Number of electron change, that is N factor. Equivalent is nothing. That is what it is. Number of moles into volume. So that here we can write number of electrons change, that is N factor. That is equal to what it is? Normality into volume. So equivalent, generally when we are speaking about equivalent means normality into volume, right? So here normality into volume. So normality of both the thing, what it is, NaHC2O4 of 2x and KHC2O4, H2C2O4, both. So we have to identify for both. So here what it is, the first one, here you will get 0.2n into volume. And the same way, this is equation 1. I just point out here equation 1. Why? Because we are going to see that sodium hydroxide versus the same point, right? NaHC2O4 and KHC2O4. Like we are going for to find out that acid base. I told no, one it is redox reaction, the other one it is acid base reaction. I told no. So now this is a redox reaction we found. Now we are going to identify that acid base reaction. So here this is the first point, first equation over. Now this is the second point, what we are going to find out. It is acid-base reaction. In this reaction, sodium hydroxide, okay, I just mentioned here, in this reaction, sodium reaction with sodium hydroxide. Okay, you remember. So KHC2O4 dot H2C2O4. So this is a mixture, right? So this is a mixture. And next one, what it is? NaHC2O4. Okay, these both. So these both acts as what it is? These both acts as what it is? Acid base reaction. Acid base reaction, right? Okay, now next one here in this, here replaceable H plus ion. That acid base reaction means replaceable H plus ion we have to identify. So NaHC2O4, that is one replaceable. Okay, one replaceable H plus ion. I just mentioned clearly for you to understand. Okay, one replaceable H plus. It takes a time, but still you have to understand thoroughly. That is what I'm just mentioning. Okay, now here one replaceable H plus ion, whereas KHC2O4 dot H2C2O4. Here how many H plus ion? Here actually what it is? Here 1, here 2. So totally 3 replaceable. H plus ion, right? Right. So total replaceable, it is actually what it is. Okay. Now total equivalent. Now we can go for total equivalent. Okay. Total equivalent. Equivalent of NaOH. First one we found equivalent of N KMnO4. Now we are going to identify the equivalent of NaOH. Okay. So first one it is 1x. Here 1x is nothing. It is 1 H plus ion. That is number of electrons replacing. Right. Plus here how many? 3x. Right. Sorry. 3y. Because we are seeing the ratio, no? So 3y, that is equal to, here what it is, they have given that normality, that is, I just mentioned here that in the question what they have mentioned, here 0.12 N, right? 0.12 N. 12 N into volume. Why? I just mentioned N into V. So normality into volume. So generally equivalent of so and so, that is normality and volume. So okay, now here 1x plus 3y, so that is replaceable, that is N factor. So this both combined, this equation, it is 2. So this is equation 1, what we have gone, that is 2x plus 2x plus 4y equal to 0.2 N normality into V. And the same way equation 2, what it is, 1x plus 3y equal to 0.12 N into V. So this is equation. So this equivalent, we are going to see that comparison, that is equivalent of potassium permanganate and equivalent of sodium hydroxide. Yes. So the equation 1 and 2, right? So we can divide 1 by 2. We can divide, right? We can divide. So 1 by 2, no? So equation 1 by equation 2. So that means here equation 1, what it is? Here 2x plus 4y divided by x plus 3y. So 1x I just mentioned. No? So x plus 3y equal to 0.2 N divided by 0.12 N into V. Into V, because volume we did. No. Okay, so volume only we have to identify the molar ratio. I mean volume ratio we have to identify. Okay, so here how do we find out? Here this is, so 2x plus 4y divided by x plus 3y, that is equal to, here what, how much we will get? So 20 divided by 12. See, here multiply both the side, multiply with the 10. So that means you will get 20 divided by 1, 2. That means 12. That 0.0 it goes, no? So that is what. Okay, now you will get what it is for both. If you cancel, you will get 5 by 3. 4 3s are 12. 4 5s are 20, right? Okay, so 5 by 3. Yes, got it. Okay, now in this point, you have to go for cross multiplication to find the value. So cross multiplication. So how do you go for it? Here, 3 into 2x plus 4y equal to 5 into x plus 3y. Right? Okay, I think you got an idea. Okay, now you have to multiply with it. 6x plus what it is? 4 3s are 12y equal to 5x plus 5 3s are 15y. Okay, now you cancel that. Okay, 6x minus 5x equal to 1x, right? And the same way 15y minus 12y equal to 3y. So here what it is? So x 1x no, so x only you can keep. So 1x equal to 3y. So x by y ratio we can identify. So x by y ratio, it is 3 by 1. Okay, 1. Okay, so molar ratio, it is 3 by 1. So that is 1x equal to 3y. So we can say that is 3:1. Okay, I hope you got that very clear idea about what it is. The molar ratio of, yeah, I just mentioned here completely. The molar ratio of NaHC2O4 and KHC2O4 H2C2O4. The mixture, these both are mixture, no? So what is the molar ratio? It is 3:1 ratio. I hope you got that idea. How do we identify? Here I just mentioned clearly. So x by y, y by x actually. Yeah, I just I got a confusion. So here what it is? Y by x. So y by x, it is 3:1. So this is what answer you got there. Okay, now what is the value they have given in the option? Okay, so actually we have to be very careful to find the answer. So y by x, so this is 3:1. So which is the correct option? Option D is the correct option. I hope you got the clarity about this question, right? Come on, let us go to the next question, right? Yeah. The next question, stannous sulphate and potassium permanganate are used as a oxidizing agent in acidic medium for oxidation of ferrous ammonium sulfate FAS to ferric sulfate. The ratio of number of moles of stannous sulfate required per mole of FAS ferrous ammonium sulfate to that number of moles of KMnO4 required per mole of ferrous ammonium sulfate. See, this is actually very simple. Here, two oxidizing agent they have given. What are those two oxidizing agents? Stannous sulfate and potassium permanganate. Both are oxidizing agent. That one, which is oxidation process, ferrous converted to ferric, right? So that is molar ratio. That is how many moles required for each oxidizing agent we have to identify. That is for 1 mole of FAS, that is ferrous ammonium sulfate. Okay, this is very simple. We can write that half reaction so that it will be easy to identify that moles ratio, right? So KMnO4, KMnO4, you know very well, it's very famous acidic medium reaction. Okay, KMnO4 in acidic medium. Okay, so KMnO4 in acidic medium, MnO4 minus, right? MnO4 minus, which is converted to Mn2 plus 4H2O. This you know very well, right? How many oxygen? That many water molecules. And how many hydrogen? That many H plus ion. And how many number of electron change? That is oxidation number. So this is plus 7 converted to plus 2. Right, so that means 5 electron change. So 5 electron change here, number of electron change, it is 5 electron change. So N factor, it is 5. Right, okay. Now, next one, ferrous converted to ferric, you know very well. Fe2 plus converted to Fe3 plus. So N factor of this, N factor. So this is 1 electron. So you have to multiply with 5. Why? Because to balance. Right now, this is for 1 mole of KMnO4 oxidizes, 5 mole of Fe2 plus ion required, right? So 1 mole of KMnO4, 1 mole KMnO4. This is cross multiplication. This is 1 electron, right? This is 1 electron. Yeah, 1 electron. 1 electron, you have to multiply with this one. That is what I didn't mention. This 1 electron, same number only. So 1 mole of KMnO4 require 5 moles of FAS. 5 moles of FAS, right? Now the next one, number of moles of potassium permanganate requires 1 mole of FAS. Sorry, number of moles of KMnO4 requires. Okay, so number of moles of KMnO4 requires. So how can we bring it? 1 by 5 can we bring it? 1 by 5. So 1 by 5 equal to what it is? That is 0.2 moles. So 0.2 moles, we can take it as what it is, Y. Because moles ratio we have to identify. That is what I just mentioned, Y. So first one, stannous, right? Stannous sulfate, so that is X, and this is Y. I hope you got that idea. Okay, so this is Y. Now here, stannic sulfate. Okay, now here, stannous to stannic, right? So SN4 plus, which is converted to SN2 plus, right? Stannous sulfate, so stannic. So here what it is? How many electron? Here 2 electron, right? So here the same, Fe2 plus, which is converted to Fe3 plus. Fe3 plus. So here N factor. So here N factor, what it is? Here N factor 2 electron, right? Here, okay, now here N factor, how much? Here N factor. So here N factor, so that you, here N factor 1. N factor 1, right? So you have to multiply this into 2. This multiply into 2, cross multiplication. Here you have to multiply with 1. And here 2, right? Okay, now number of moles, the same. 1 mole of stannous sulfate oxidizes 2 moles of what it is, FeSO4. So that means FAS, right? So number of moles of what it is, SnSO4 twice to SnSO4. So stannic to stannous. So here requires. So here 1 by 2. So that is FAS also, right? So 1 by 2 means how can you bring it? 0.5 moles we can bring it now. So 0.5 moles, this is, we can bring it as X. So this is X and that is Y now. So here this is X and that is Y, right? Okay, now final mole ratio. Okay, final mole ratio, right? final mole ratio. So here x by y equal to 0.5 divided by 0.2. So you will get what it is? 2.5, right? 2.5. So moles ratio, it is 2.5, right? Okay. So 2.5, what is the options they have given? Here 2.5. Yeah, here is that. So the answer, it is 2.5. This is the answer. Yes, this is. Okay, so option, it is option A, right? 2.5. I hope you got the clarity. Yes, come on, let's go to the next question. Here, if A gram is the mass of sodium bioxalate required to neutralize 100 ml of 0.2 m sodium hydroxide, and B gram that required to reduce 100 ml of 0.02 m KMnO4 in acidic medium. So that is actually A and B comparison question, A and B. So here two reactions are available. One, it is acid-base reaction. The other one, it is redox reaction. So we have to identify the moles ratio. So in that way, A equal to B, 2A equal to B, A equal to 2B, none of these. So easily we can identify. If we write the equation and we can identify that what it is, redox reaction as well as equivalent of each thing. So we will find the number of moles ratio easily. Okay, now here I just mentioned that equation. So sodium bioxalate C2O4 plus NaOH. So that is gives what it is, Na2C2O4 plus H2O. So this is acid-base reaction. So acid-base reaction, salt and water, it is naturally. Okay, so here number of moles, actually this is 1 mole and this also 1 mole, right? So number of moles of sodium hydroxide. So number of moles of sodium hydroxide. So here in this point, number of moles of sodium hydroxide given mass by molecular mass. But here they have given what it is, molarity and volume. So molarity into volume in liter. So here what it is, here 0.2. First one what it is, 0.2 only now. So 0.2 into 100 ml we can convert it into liter. So that means 100 ml we can convert 0.1 liter, right? So what is the value you'll be getting? You'll be getting 0.02 moles. Which moles? It is actually NaOH moles, right? Now next one, since it is 1:1 only now, because sodium bioxalate and sodium hydroxide both are 1 moles only now. So 1:1. So this is, since 1:1 ratio, number of moles of sodium bioxalate, it is that only, right? So moles of number of moles of sodium bioxalate C2O4, that is 0.02 moles, because both are same, right? 1 so this also same and that also same, right? Now molar mass we have to identify. Why we have to go for molar mass? Because easily we can identify the given mass. Okay, so molar mass of sodium bioxalate, how much it is? 112 gram per mole, right? So given mass equal to what it is, moles into molar mass. Generally number of moles equal to given mass by molecular mass. But now here what it is, given mass we have to identify. Why? Because A gram, B gram they mentioned. No, so given mass equal to number of moles of so and so into molar mass. I hope you got the idea. Yes, moles, how much it is? 0.02 into 112. Here this is 112 gram per mole. So this only given mass, A gram they mentioned, no. So this actually what it is, 2.24 gram. Given mass it is 2.24 gram. That is given mass of what it is, NaHC2O4. I hope you got that idea. This indicates actually A gram. Right now we have to identify B. Okay, come on, let us check that B. Okay, in the acidic medium, oxalate ion. So here in the question it has mentioned very clearly. Here I just write it here so that it will be easy. In acidic medium, oxalate ion C2O4 2 minus from NaHC2O4 acts as reducing agent, right? Reducing agent. And the same way here, KMnO4, this acts as oxidizing agent. Right. So here N factor easily we can identify. So N factor of oxalate ion, N factor, number of times we have identified this. N factor of C2O4 NaOH, 2 minus. How much it is? You know very well. 2 electron. The 2 electron, that means in factor it is 2 of oxalate ion. And the same way, n factor of MnO4 minus. How many? 5 electron. No need to write it that many times. We have done that practice. Number of questions with the different values, right? So you know very well. So moles of, here also we have to find it because question it is moles ratio only, right? So A equal to what? B, or A equal to B, or A equal to 2B, like that. So moles of KMnO4. KMnO4. So here what it is? Come on, number of moles. Again, we have to find out that number of moles. Number of moles of KMnO4. So here's number of moles. How to identify? Here molarity into volume of solution in liter. This is molarity, right? Remember that. So here you will get what it is molarity. What they have given 0.02 m into volume of solution 100 ml. So here converted into liter 0.1 liter. Right. I hope you got that. So number of moles, how much? 0.02 moles. So number of moles of KMnO4 0.002 moles. Okay. Now equivalent of KMnO4, let us identify. So equivalent of KMnO4. So that is equal to number of moles into n factor. Generally, equivalent of so and so here, normality into volume of solution, volume only, n into V only will do that. But here, moles ratio they are asking. So moles ratio means here we have to identify number of moles into n factor, number of electron change. So here moles, how much here? 0.002 into n factor of KMnO4, it is 5. Okay, so you will be getting what it is. When you calculate these both, you will get 0.01 equivalent. And the same way, here what it is? Equivalent of NaHC2O4, that is equal to equivalent of KMnO4. So that is 2 and 5. Already you have known that. Okay, come on. Now number of moles of number n, it is number of moles of NaHC2O4 into 2. This is 4. Okay, into 2, because 2 electrons, right? So number of moles, that is equal to what it is? 0.01. Here we have identified now 0.01. Okay, so that is equal to the same number of moles of sodium bioxalate. So that is equal to 0.005 moles. Right? Okay, now here what it is? B equal to, so this is B. Okay, B equal to, here what it is? 0.005 mole into given mass. We are finding out now given mass. Given mass, right? Given mass of so and so. Okay, so here number of moles 0.005 into 112. This only, right? So gram per mole. Right now here how much you are gaining? Here you will be getting 0.56 gram. So compare that A and B. A, how much it is? A equal to 2.24 gram and B is equal to 0.56, very less, right? Comparatively 0.56. Okay, now A by B, moles ratio we have to identify now. A by B, okay, 2.24 gram divided by 0.56. When you calculate A equal to 4B, you will be getting. Here the answer, it is 4. So A equal to 4B. So this is the answer, A equal to 4B. Okay, so this is the answer. Okay, so now let us check the answer. I hope you got that idea how to identify. This is a ratio. All these questions based on ratio, molar ratio, number of moles of ratio, comparatively these questions, right? Comparison question, N1, V1, and yeah, A equal to. So A equal to B, this is not the correct one. Okay, so A equal to B, it's not correct. 2A equal to B, this also is not. A equal to 4B, right? So this also it's not correct. None of this. Actually, what is it? A equal to 4B. They might have given this option. So that option has not given none of these. So this is the correct option. I hope you got the clarity about this question. Come on, let's go to the next question. The next question, 2 mole equimolar mixture of Na2C2O4 and H2C2O4 required B1 liter of 0.1 m KMnO4 in acidic medium. For complete oxidation, the same amount of the mixture required B2 liter of 0.2 m NaOH. For neutralization, the ratio of B1 to B2 is. See, here also they are asking about the ratio of volume, because here the same thing. We have to identify that oxidation process as well as reduction process. So 2 mole equimolar mixture, that is sodium oxalate and oxalic acid required this point, and the same way that is for oxidation, and the same amount required for V2, that is for neutralization. Okay, come on, let us go through this idea. So oxidation with what it is KMnO4. Okay, so oxidation with KMnO4. Right, so oxidation with KMnO4, what it is? Na2C2O4, and what it is? H2C2O4. Both can be oxidized by, I'll write both the thing, both can be oxidized by KMnO4. Right, okay, now equimolar mixture. Okay, so equimolar of the mixture. Okay, so equimolar mixture. Equimolar mixture. So 1 mole of Na2C2O4 and 1 mole of, okay, so this is 1 mole of NaHC2O4 and 1 mole of H2C2O4. So you will be getting here what it is. In this, how many, what it is, n factor. So here actually 1 and here actually 1. So here number of electron change, here 2, here also number of electron change 2. So here all together, here actually what it is, 4 equivalent. So you will be getting what it is, 4 equivalent. Right, now equivalent of KMnO4, now we have to identify. So equivalent of KMnO4 equal to molarity into volume of solution in liter. So here molarity, what they have given in the question, 0.1 into V1 into number of moles, right? So n factor. So here what it is, 5 electron, right? So in that equivalent of KMnO4, it is 4. Just now we found that now. Equivalent of KMnO4 in oxidation process, 4 equal to this, that 4. So 4 equal to 0.5 into V1. So V1 we can bring it this side. So V1 equal to 4 divided by 0.5. So you will get what it is, 8. So here V1, no, so volume, so liter, we are mentioning in liter. So V1 equal to 8 liters. Now we have to identify V2. I hope you got that idea. See, this is a ratio, like comparison. Now reduction process, like neutralization. Okay, reduction with what it is, NaOH plus H2C2O4, like acid base. Okay, so H2C2O4 plus NaOH. So you'll be getting Na2C2O4 plus H2O. So balancing here 2, because 2 Na2, right? So here 2 H2O. Here, no? So yes. So you'll be getting this. Right, now that n factor, the small n. Okay, n factor, number of electron change, it is 1. N factor of NaOH. Right, H plus ion, how many electrons replaces? It is 1. Right, H plus ion. So here H2C2O4, n factor. Here what it is? 2 electron, here 1 electron. Right, now total equivalent, what it is? Total equivalent of acid equal to 1 mole into 2. So that is actually 2 equivalent. Okay, now we got both the equivalent. So equivalent of NaOH equal to molarity into volume of solution in liter. So equivalent here, what it is, 2 equal to molarity, what it is, 0.2 into volume of solution. Here what it is, n factor, no, n factor. Right, so into what it is, 1. N factor 1 only, no, sodium hydroxide only 1, no, H plus ion replaces. So you'll be getting what it is. What is the answer you'll be getting? So you'll be V equal to, so V2 here we can bring it. V2 equal to 2 by 0.2. Here 0.2 into 1 only, no, same. So equal to what it is. Here you will get what it is, 10 liter. Right, now V1 and V2 we can go for the ratio. Ratio equal to V1 by V2. So V1 what it is, 8. V2 what it is, 10 liter both. So you'll be getting what it is. Can we go for 4 by 5? So 4 by 5 equal to 0.8. So ratio it is 4 by 5. So 4:5 can we go? V1 and V2. Okay, see, these are all comparison ways. So simple, like if you know that idea of these formulas and how to apply the values, it's easy. just to get that idea of what it is concept. So values, it cannot be the same. The same, some other values also, same idea you can follow. So 4:5. Yes, you got the answer, 4:5. Hope you got the clarity. Come on. Let's go to the next question in our next video. I think you got some ideas through these questions and what it is, getting idea about to know that how to solve such kind of problems. And thank you for watching.